Sometimes it does that, sometimes it doesn't. Hey, this is solving systems of by substitution, part 1. A system of equations. Still, same thing, a collection of 2 or more equations. So we're back to equations. 3.3 was the only inequalities we'll deal with. We are back to equations for the rest of the unit. Our solution to our system is still the point that makes both of our equations true. On one problem, I will show you how to plug in and check your answers, but I'm not going to have you write it out every time because that takes a long time. Okay, here are your steps to solving a system by substitution. They are lumped together because these 2 steps go together and these 2 steps go together. Step 1 says to solve one equation for x or y. It is crossed out because you do not have to do that step today. On Monday when we do 3.5, you'll have to do that. But for today, that step is already done for you. Step 2 and 3 are to substitute that equation, the equation that's solved for x or y, into the other equation and solve that equation for the first variable. So we're going to go do steps 2 and 3 on the first system. So moving down, our first system here. Our first equation is solved for y. It is y equals x plus 8. So if y equals something, we are able to replace the y in the other equation with something that is equal to y, because that's the way equations and equality work. So since y equals x plus 8, we can take this x plus 8 right here, and we can plug it into our other equation where the y is. So what that's going to look like is I'm going to take my bottom equation and I'm going to rewrite it. I'm going to have 3x plus 3, but instead of the y, I am going to put in x plus 8 in parentheses. And then I keep writing the bottom equation. It is equal 6. So that's the exact same as the bottom equation, except for the y has been replaced with an x plus 8. And the reason why I'm allowed to do that is because y equals x plus 8. Any questions about that? Okay, that right there is really the only new part of this section of the equation, because we know how to solve from here. We, back in 1.4 and 5, did equations with distributing and combining like terms. So now we have just x's. So the goal is to only have x's now, because we replace the y in terms of x. Another thing with substitution, when I get a substitute teacher, they replace me for the day. So when we substitute in for something for y, the y leaves because it's being replaced. All right, so now we can distribute and solve. 3 times x is 3x. 3 times 8 is 24. I've still got this 3x. And is equal to 6. So that's distributing. What is the next thing I can do? What's the next thing we did on our quick write? Add the x's. What is that called? Combining like terms. Yep, so 3x and 3x is 6x plus 24 equals 6. And then now we're back to 1.1 type equations where we're just solving a normal equation. So we're going to subtract 24 from both sides. We'll get 6x equals negative 18. Divide both sides by 6. We will get x equals negative 3. Okay, So, with substitution, we have now solved for x. With every system, your answer is going to be an ordered pair. We need to solve for both x and y. So now we are ready for steps 4 and 5. Before I move on to that, does anyone have any questions? Okay. So step 4 is to substitute your solution you just got into the other equation so we can solve for the second variable. So we know what x equals. Now we want to figure out what y equals. So we're going to go back to our original equation. We are going to use the one that's already solved for y. Y equals x plus 8. So I'm going to write that down right here so I know what I'm using. And then we are able to plug in the fact that we now know that x equals -3. That can get plugged in for this x right here. So we will have y equals -3 plus 8. So we replace the x with that -3 because we now know what x equals. And then -3 plus 8, same thing as 8 minus 3, is 5. So we get y equals 5. And then the last thing that we do is we write our answer as an ordered pair. So it's always x comma y. So it's -3 comma 5. Okay. Any questions about this first problem? All right, we're going to do another one then. So let's go down. I will continue to read steps as we go. So step 1 was to solve one equation for x or y. That's already done. Do we have an x equals equation or a y equals equation? X equals. So that second equation is an x equal equation. So this x equals 2y plus 5. Where are we able to plug that in? For the x in the other equation, because it is x equals. Okay, so I'm going to go and write that down. So I'm rewriting my top equation now. 3 times 2y plus 5. Close my parentheses. And I still have minus 2y equals 19. So that's our big new step, is the substituting. Any questions on substituting? Okay, then we can distribute and solve. So 3 times 2y is 6y. 3 times 5 is 15. I've still got minus 2y equals 19. After I distribute, what do I want to do? Combine like terms. 6y and -2y is 4y plus 15 equals 19. And then it is smooth sailing from there to solve for y. We're going to subtract 15 from both sides. 4y equals 19 minus 15 is 4. Divide both sides by 4. We will get y equals 1. If you have messy handwriting, the letter X and the letter Y look really close to each other. So make sure it's very obvious to you and to us whether it's an X or a Y. Because if you don't know whether it's an X or a Y, you're not going to know which part of your answer it is and where to plug it back in. Okay. Now this one we solved for y first. We still need to go solve for x. So we're going to take our equation that's already solved for x. X equals 2y plus 5. We now know that y equals 1. So we can take that 1, we can plug it in for y. So we will have x equals 2 times 1 plus 5. Two times 1 is just 2. So now it's 2 plus 5. And then 2 plus 5 is 7. So we get x equals 7. And we can write this as an ordered pair. 7, 1. Okay. Questions right now? Okay, there's 2 more on the back. They're super fast. Don't flip over yet, though. I want to show you. You can check your answers here, though. This is my x and this is my y. So if I wanted to plug these back in, I would plug them in for x and y back into my original equations. What's 3 times 7? 21. Minus 2 times 1. What's 2 times 1? 2. 21 minus 2 is 19. So that one works for there. And then we could plug in here too. So we would want to make sure that 7 equals, so x equals 2 times y, so 2 times 1, which is 2, plus 5, 7 equals 7, that works, okay? So you could always plug your x and your y back in to make sure that they both are correct. All right, flip this over. We've got 2 more problems on the back. And you're like, oh my God, 2 whole more problems? They're fast, because there are special cases. This first one, do we know what x equals or y equals? Do we have an x equals or a y equals equation? X equals. So we are able to take this x equals equation. Where can we plug it in? For the x, because it's x equals. So we're plugging it in there. So 2 times, plugging in x, 3y plus 2, minus 6y equals 8. What is 2 times 3? 6. So now we've got 6y. And then 2 times 2 is 4. So 6y plus 4 equals, or minus 6y equals 8. Any questions about the distributing? Okay. Now what do we do? Combine like terms. What happens when we combine like terms? They all disappear, yeah? Because 6y minus 6y is no y's. So we've got 4 equals 8 now. Does 4 equal 8? No. When our variables all disappeared and we are left with a false statement, way back 1.7, do we remember what our answer was? No solutions. So if you are left with a false statement, just put a little note to yourself if you need to, we have no solutions. You can write no solutions, you can write no sol. Don't just write down no, because that tells me that you're just not going to do that problem. At least write down no thank you. No thank you. All right, questions on that guy? All right, the last one, and then we'll have about 20 minutes to work. We are plugging in for y on this one, because we have an equation that is y equals. So we've got y equals 2x plus 8. That's going to get plugged in here. Because there's that minus there, I would strongly recommend putting an imaginary 1 right there. So it's minus 1y. It's going to make your distributing easier. So we've got 2x still, minus 1 times our 2x plus 8. That's what we're plugging in for y, and that is equal to 8. Okay, we're going to distribute this negative 1 to the 2x. So still have 2x. Negative 1 times 2x is minus 2x. Negative 1 times 8 is negative 8. Ooh, and I missed a negative here. This was equal to negative 8. This is equal to negative 8. Okay? When we combine terms, my x's are going to cancel. I think you guys all saw that coming. 2x minus 2x. What I have left is negative 8 equals negative 8. Does negative 8 equal negative 8? Yeah, so that's true. If our variables disappear and we are left with a true statement, how many answers do we have? Infinite solutions. All right, questions, concerns, emotions, thoughts, anything. Okay, I'm going to stop this video then. If you would like for us